Good morning. Today's class we shall discuss about the pulse code modulation. So pulse code modulation, it's a method that is used to convert an analog signal to digital signal so that the modified analog signal can be transmitted through a digital communication network. So the PCM, pulse code modulation is, in short, it is indicated as PCM. So it is in binary form. So there will not be only two possible states are there. So there's input signals that can be represented in two states. That is, it may be in say symbol 1 or 0. So the transmitted analog signal that will be recovered at the receiving end by the process of demodulation. So the pulse code modulation process, this pulse code modulation is done in three steps. One is sampling, next step is quantization, third is the coding. So there are uh, two specific types of pulse code modulations. They are named as differential pulse code modulation and adaptive differential pulse code modulation. So it is named, it can be represented as DPCM and ADPCM. So this is a general block diagram of pulse code modulation. So first of all, it has three parts. One is the transmitter, channel, and the receiver. So on the transmitting end, it has the source, low pass filter, sampler, quantizer, and encoder. And the transmission path, the signal will be transmitted, and the receiving end, the reverse of the transmission process is done. That is regeneration circuit, decoder, reconstruction filter, and the destination. So first of all, in short, we can say that first of all, the signal from the source is a continuous time signal. So it may be an analog signal, or it will be a voice or speech, whatever it is, that will be a continuous time signal. So that is generated from the source and it is passed through the low pass filter. So next, the noise component, the nonlinearity is present in the system, and the signal is get eliminated and it is given to the sampler circuit. So here the sampling process is done. So here the sampling is done according to the Nyquist criteria. So at the periodical time intervals, samples are collected and then it is given to the quantizer. The signal then the signal is rounded to its the equal to its quantization levels and it is given to the encoder. So encoder, there are channel encoders will be there, so that will convert the signal that should be suitable for transmission through the channel. So thus at the end of the encoder, the PCM signal is generated. It consists of number of ones and zeros. And the generated PCM signal is transmitted through the transmission path. So in the transmission path, we can use a number of regenerative repeaters. The purpose of the regenerative repeaters is to boost up the received signal strength. So because of that, the noise can be eliminated and only the signal strength will be boosted while transmission. So the regenerative repeaters generate the same signal that is transmitted at the transmitting end. So because of that, the noise effects are get eliminated, and the receiving end, the signal is received as such that the signal is transmitted. So on the receiving end, the received signal is decoded and then passed to the reconstruction filter. So in which the nonlinearities present or added in the transmission path is get eliminated and the signal is curve is get smoothened, and it is from the reconstruction filter, the from the sample values, the original signals are recovered. So thus the digital signal is converted into analog signal, and the final reaches the final destination. So it's elaborated in the following session. That is, the sampling is a process of measuring the amplitude of the continuous time signal at discrete instance, converts the continuous time signal into discrete signal. So the sampling process which generates a flat top pulse amplitude modulated signal. Next, quantization. So in which an analog sample with an amplitude that is converted into a digital sample with an amplitude that takes one of a specifically defined set of quantization values. So this quantization is done by dividing the range of possible values of all the analog samples into different levels and assigning the center values of each level to any sample in the quantization interval. So this quantization approximates the analog sample values with the nearest quantization values. So almost all the quantized samples and differ from the original samples by a small amount. That amount is called the quantization error. Next is the regenerate repeaters. The signal strength can be enhanced through these regenerate repeaters. So the channel outputs are includes regenerate repeaters to balance the signal loss, run away the signal, and also increase the signal strength. Decoder, the main function is to decode the pulse coded signal to repeat the actual signal. So this gives a set of the demodulator. Finally, the original signal is recovered at the end of the demodulator and it is given to the destination end. Thank you.